Well, good morning, students. We have a decent population now. Let us start our class. Okay, I hope you can see the whiteboard. So, last class we talked a little bit about the determinant, and today's class will also be something similar to that. Like these are the things that you must have studied in your undergraduation level, and mm, for the sake of completion, I must tell you about this. You, all of you guys must be knowing about this, but then just for the sake of completion, one of the important concept that is required to understand is the Gaussian elimination process. Uh,
Sir, please start the recording.
Recording, yeah. Thank you. So we'll start with that. Okay, so let me take a system of equations and go for this Gaussian eliminations, and the best way to understand this is through an example. Let me take a system of equation. Let it be uh, minus x1 plus x2 minus x3 equal to minus 1, 6x1 minus 6x2 plus 7x3 equal to minus 7, 3x1 minus 4x2 plus 4x3 equal to minus 6. And how do we write this? And this system of equation, we need to write it in the form of ax equal to b. So how do we write that? We write a as all the coefficients of x1, x2, x3. So the coefficients are minus 1, 1, minus 1, 6, minus 6, 7, 3, minus 4, 4. This is our A, followed by x1, x2, x3, and this gives, when you multiply this first row with the first, the only column, that is x1, x2, x3, the result that you get is minus 1. Second row multiplied by the column x1, x2, x3, the result that you get is minus 7, and this is minus 6. This is what you get. So in the Gaussian elimination steps, the very first step is to um, the very first step is to write the augmented matrix. And the augmented matrix is nothing but the matrix A appended with matrix B. So let me write that: minus 1, 1, minus 1, 6, minus 6, 7, 3, minus 4, 4, and here I append the uh, B matrix, that is minus 1, minus 7, minus 6, and I try to do some row operations on this. So this I can write it as the target here is to make it an upper triangular matrix. What is upper triangular matrix? That is the diagonal element. The diagonal element would be this diagonal elements. We'll try to keep it, below the diagonal elements, we'll make everything 0. That is what the target is. And in order to achieve this, we need to go for certain row operations. And the row operations, like we will be taking this one, we'll be taking this element as our pivot element, and that is what we'll be doing. R2, this is our pivot element, minus 1. So below minus 1 will be making, so we'll manipulate row 2, we'll manipulate row 2 as row 2 plus 6 times row 1. So we'll write the row 1 as it is, minus 1, 1, minus 1, minus 1. Row 2 would be R2 is equal to R2 plus 6 times R1. So uh, 6 times R1, this becomes 0. This becomes 0. 6 times R1, so this also becomes 0. 6 times R1, that is minus 6. 7 minus 6 is equal to 1. 6 times R1, that is minus 6, minus 7 minus 6 equal to minus 13. Similarly, R3 is equal to R3 plus 3 times R1. So this I can write it as 0. And 3 minus 4 is minus 1. Minus 3 plus 4, 4 minus 3 is 1. This is minus 3, minus 6, that is minus 9. That's it. What the next we can do is, we can simply, if we can swap the rows, that is adequate enough. So that that becomes minus 1, minus 1, 1, minus 1, minus 1, 0, minus 1, 1, minus 9, 0, 0, 1, minus 13. Okay, that's it. So we have an upper triangular matrix, and from here easily one can through backward substitution. You can easily find out what is x3. The system of equations now becomes minus x1 plus x2 minus x3 equal to minus 1, minus x2 plus x3 is equal to minus 9, x3 equal to minus 13. So you have x3 here, x3 equal to minus 13, x2 is equal to 9 plus x3, that is equal to 9 minus 13 equal to minus 4, x1 is equal to 1 plus x2 minus x3, that is 1 minus 4 plus 13, 10. That's what the answer is. So just a kind of déjà vu. I hope you know what is déjà vu. So you have experienced all these things. It's a repetition of whatever you have experienced earlier. So in this déjà vu, you must have experienced what is reduced echelon form. Reduced echelon form. The next one is the in reduced echelon form. The target is always there are some properties in reduced echelon form. The properties, let me write. The first non-zero element, row element. The first non-zero row element in each non-zero row, each non-zero row is unity. Well, yeah, let me write, then I will tell. Unity, and it is called as, it's called as leading element. Number B, all the non-zero all the non-zeros all the non-zero rows precede the zero rows. If any. And the third property, the number of zeros before the leading element let this right. What happened? The number of zeros before the leading entry in in each row is less than the number of such zeros in succeeding rows. So row echelon form. Okay, the example that we saw in the previous case, in this case, this in fact is a row echelon form. However, in usual Gaussian elimination cases, you may not get unity here. You may not get unity here. Here in this particular example, you have got unity, but it may not be. But this is a good example for reduced echelon form where the elements are elements below the pivot elements are all zero. So these are the pivot elements that we have achieved. This is the pivot element that we have achieved. And below the pivot element, everything are zero. So that is a reduced echelon form. And there is also something called as um, reduced row echelon form, or known as RREF. So here what happens, we try to make everything zero above and below, both above and below the pivot elements. Let us take an example and try to understand it. So yeah, the target is one thing is all pivots are one. This is one thing we need to make. And above and below pivots are all zeros. So the operations are more or less same. We can rescale a row. We can rescale a row. We can add a multiple of one row to another, and another operation we can swap. The other things we can do. Let us take an example. So the first step here, I'll make this element as the pivot element. And let me perform few operations. Let me write R2 is equal to R2 plus minus 4 times R1. Yeah. And R3 is equal to R3 plus minus 6 times R1. So first row doesn't change. Second row, first element becomes 0. 4 into 4 into 2, that is minus 8. 5 minus 8 is minus 3. Minus 4 into 3, minus 12. Minus 12 plus 6. 6 minus 12 is minus 6. 4 into minus 4 into 4, 16. 7 minus 16 is minus 9. Similarly, this one is 0. 6 into 2, minus 6 into 2, 7 minus 12 is minus 5. And 18 minus 18, 8 minus 18 is minus 10. And minus 24. So 9 minus 24, minus 15. I guess this is correct. Yeah. So I think this is correct. Yeah, this is correct. So what's our target? Target is make everything below and above the pivot element 0. So one of the pivot element we have already decided that is 1. And next will be minus 3, of course. But here there is one thing I can see here, that the second row is a multiple of, and third row is also a multiple of minus 5. So what I can write here is R2 is equal to minus 1 upon 3 R2, and R3 is minus 1 upon 5 R3. So this would make life little bit simpler. 1, 2, 3, 4, 0, 1, 2, 3, 0, 1, 2, 3. Wow, beautiful. Okay, two rows are same. We have two rows which are same. So what is next? Let us make one of them as pivot. Let us make this one as pivot. and we have R2 is equal to uh, no, we are making R2 pivot, right? So why I'll change R2? We're making R2 pivot. Sorry. We'll make everything above R2 is everything above this pivot element as 0, everything below the pivot element as 0. So we'll start with the upper one, R1 equal to R1 minus 2 times R2 and R3 is equal to R3 plus minus 1 time R2. So middle row is as it is, 1, 2, 3. Upper row, first element doesn't change because this element is 0. So the first element doesn't change. The second element becomes 0. Now the third element, R1 minus 2, R2, yeah, second element 0. Third element is 3 minus 4, that is minus 1. And the fourth one is 4 minus 6, that is minus 2. Minus 2, yeah. R3 is equal to R3 minus R2. So this becomes 0. This becomes 0. This becomes 0. This becomes 0. Okay. So we have two pivot columns. We have one pivot column here. This is one pivot element. This is another pivot element. So this is one pivot column. This is one pivot column. Here this is 0. It's okay. This is what the reduced row echelon form, where everything below the pivot elements are 0, everything above the pivot elements are 0. Okay. So how do we exploit such reduced row echelon form to compute the inverse? How it is being done? Inverse. Okay. It's something like I have a matrix A. Uh, let us say A inverse. A times A inverse is equal to the identity matrix. So what exactly this means? This actually means that the original matrix, the original matrix multiplied by the, yeah, this matrix, I mean, what's the multiplication actually? Matrix A times uh, ith column of A inverse, it will give you um, I mean, it's not matrix A actually. The first, uh, let us write it in the form of, let me write this one J and ith row of matrix A, ith row of matrix A, jth column of, um, yeah, that gives you what you call identity matrix. What happened? Let us not write I. I have used E. Let me write IJ. Now, if somehow I can say that, let us say -3 to -1, 6 -6, 7. Just a minute. What was the matrix that we took earlier? Let us take that. That will be easier. This gets hanged again and again. Oh no. Well, let us start with another matrix. That's okay. -3 to -1, 6 -6, 7, 3 -4, 4. Yeah. So what I'll write here, I'll write the augmented matrix, but I'll not augment with the right hand side, that is B. Rather, I will augment it with the identity matrix, that is -3, 2, -1, 6, -6, 7. Our target is to find A inverse. 3, -4, 4. And I'll augment it with the identity matrix. So here we have the partition. This is my A, this is my I. And as we proceed further, our target would be this part to make A, this part to make I, and this part to make A inverse. Okay, so let us start with this. The very first step would be is equal to, what I'll do here is again the pivot elements. We have the pivot element as -3. -3 is our pivot element. So I can do one operation here. R2 is equal to R2 plus 2 times R1. That's one operation I can make. Another operation is R3 is equal to R3 plus R1. That way I will get 0 there. So let me write the first row as it is: -3, 2, -1, 1, 0, 0. Just a second, I'll be back in a minute time. Please start doing that. Um, 17. এটা ফার্স্ট এক্সাম না লিখি দেন স্যার কিছু পছাড়লে ঠিক আছে। Okay, sorry for the disturbance. Yeah, have you completed? What's the answer? Sir, नमस्कार सर टिके 10 मिनट छाड़ी कॉल कर आपको क्लास रे আছে yes yeah, have you completed it? Yeah, R2 equal to R2 plus 2R1. That is, this becomes 0. This becomes 4 minus 6 minus 2. Then 7 minus what happened? This is minus 2. This is 1 0 1. Go to the next step. Next step, let us make R1 is equal to R1 plus R2, and R3 is equal to R3 plus minus 1 R2. So we have this matrix now. Is that right? Yeah, that's right. So we, okay, what's the pivot element that we have taken? Now we'll be taking minus 2 as the pivot element, right? Okay. So the middle row doesn't change. Middle row doesn't change. Upper row is just an addition of these two. So this one doesn't change, minus 3. This one becomes 0. This one becomes 4. This one becomes 3, 1 and 0. Similarly, the bottom row, this one doesn't change. This one becomes 0. This one becomes minus 2. This one minus 1, minus 1, 1. Okay. So let us make now this one as the pivot element and start working on it. So R1 is equal to R1 plus 2 3 R1 equal to R1 plus 2 times R3. R2 is equal to R2 plus 5 by 2 R3. So now we have fractions. So last row will be as it is, 0 0 minus 2 minus 1 minus 1 1. The first row would be minus 3 0, and this one will also be 0. This will be 1 minus 1 2. Yeah, that's correct. What about the middle row? This becomes 0 minus 2, 0, minus half, minus 3 by 2, 5 by 2. Okay. Now look at this. We have the pivot elements minus 3, minus 2, minus 2, and all the elements above and below the pivot elements are 0. And now we are done almost. We can scale it and make the pivot element as unit, and we are done. So this is equal to, the operations would be R1 is equal to minus 1 upon 3 R1, R2 is equal to minus 1 upon 2 R2, R3 is also minus 1 upon 2 R3. So simply I can write this one in a simple way as 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, now come to here. Minus 1/3 plus 1/3 plus 2/3 and write it clearly, plus 2/3, and the next one is 1 upon 4, 3 upon 4, minus 5 upon 4. This becomes 1 upon 2, 1 upon 2, minus 1 upon 2. So now we have the identity matrix on the left and A inverse on the right. This is my identity matrix. This is my A inverse. So now you may multiply A inverse and check how much you are getting. You must get I. Okay. So we are continuing with déjà vu sessions. Last class was déjà vu, this class was déjà vu, another one more class will go for déjà vu, and then we'll be looking for something new. Okay, so please practice as much as you can. You may expect 1 or 2 questions from this process in the exam. Thank you.
Thank you, sir.